thank you so much, everyone, for coming into our office. We're really excited to open up our office to everyone as part of Waterloo Tech Week, second day of Waterloo Tech Week. My name is Dave. I'm a director of engineering here at Faire. So I'm going to be your host and MC tonight. We're going to kick things off in a little bit with a fireside chat, and then we'll follow up with our presentations at the end, and then again a happy hour. But first, I want to really thank everyone for coming out. I want to thank everyone who helped organize this as well. These events are a lot of work to put together. A lot of work went into this behind the scenes. So thank you, everyone. Maybe just a quick round of applause. Thank you. So just a quick overview, like I went over. We're going to kick things off in a few minutes with a fireside chat. We've got Marcelo and Yvonne here. We're going to ask a few questions, and then we'll take a quick break. Bathrooms are around the corner. We've got food and beverage for everyone. Please help yourself at any time. And then we'll go into our tech talks. We have 6 talks from engineers here that are going to go through how we're using AI at Faire. And then we'll wrap things up. Everyone will be here to answer questions, mingle, have a happy hour, and then we can close things down. We have a raffle as well to close things out at the end of the night. So I hope everyone kept their tickets. Yeah, quick reminders. Washrooms are at the back. And then as well, we have office tours are available for anyone who wants to take a quick tour of our office. Just grab an employee. Anyone with a Faire shirt on is happy to kind of walk you through our office. Also, there's QR codes around if you're interested in any of our open roles as well. So I would like to make sure everyone is familiar with what we do at Faire, what's our mission, how we serve our customers. So we are a platform and a marketplace for wholesale retailers and brands. So what is a retailer? A retailer could be anything from a clothing boutique, home and decor, gift shop, even restaurants and grocery stores. Brands are a variety of makers, big and small, some very niche, some very large. They could be anything from like large publishers like Penguin Random House to like self-care brands like Quiche, or even like packaged food like Momofuku. So we have hundreds of thousands of retailers and tens of thousands of brands. So we're an asymmetric marketplace with retailers doing all the buying on our marketplace and our platform. So here in Southwestern Ontario, we have tons of customers. Some down the street, we have Charmed Flowers and Gifts. We have Vincenzo's, who's actually catering tonight. Great place to grab a sandwich and get groceries. And then we were also have a variety of other local retailers that we support, also in Kitchener as well. So we were founded in 2017. We have one of our founders, Marcelo, here. Originally, ex-Square employees that founded Faire. And we're going to kind of walk through with Marcelo some of our founding history and past, and lead into our AI presentation. So just to quickly anchor on what our mission is, we're only successful as a company if our customers are successful. We really want to strengthen our local communities and support local retail. That is one of the core value props of our company and our platform. So our goal is to connect retailers and brands together, help them build a relationship, and then grow and stock their stores with those relationships that will grow over time. So we want to make our main streets a more diverse, a more vibrant place so that we can enjoy all these local independent retailers and can continue to support them. So the topic tonight, how are we using AI to transform wholesale, both in our internal development system and how our developers work, as well as in building features for our retailers and our brands to help better connect them in our marketplace. So our primary engineering offices are here in Waterloo and KW. We have another office in Toronto. We have an office in San Francisco. And most of our engineering teams are split between those 3 offices, with the majority here in Canada, covering like product, data, IT, and infrastructure. All our presenters here are engineers. We have 6 presentations lined up for you, and then we'll all be here afterwards for our happy hour. So we're really excited to showcase the work that we have. We have also a great blog you can check out later. And we try to highlight some of the interesting problems that we've come up with and come across, and share that with the rest of the community. So check out our website. We also, like I said, we have QR codes up if you're interested in any of our open roles. So without any further delay, I'm going to turn things over to Luke, who's going to talk to you about agentic development.
Alrighty. Hello, everyone. My name is Luke Beering. I'm an engineer on the platform team. And today I'm going to talk about agentic development. So to kick off, agentic development is a buzzword in the industry at the moment. So just going to give it a specific definition that we mean when we talk about it here at Faire. Agentic development is using AI agents to assist with any stage of the software development lifecycle. So this could be designing the feature ahead of time, putting together a PRD, writing the code, testing the code, reviewing the code, deploying the code to production and monitoring. An AI agent, we mean any tool that's leveraging an LLM in an interactive loop to achieve a task on your behalf. So coding agents, of course, are just a subset of agents that are tailored for coding tasks in particular. This is a really heavily contested space. So up on the slide, you can see a lot of the options that we've tried out at Faire for their efficacy at particular tasks. Today, though, we're focused on background agents. So these are agents that will execute tasks autonomously and asynchronously for you in a virtual machine. And in particular, at Faire, we've lent in on GitHub Copilot initially. And I'm going to talk about why that is. So the primary reason was that they have a programmatic invocation available. So we are able to use the GitHub API to kick off work in the background agent. You're also able to customize the instructions for Copilot, the setup steps for the virtual machine that it uses, and it had access to our MCP servers, which gives it proprietary information on achieving the task. So the way that we set this up is we crafted our own MCP tool, which will delegate work to the Copilot agent. So if you're in Slack chatting to our chatbot, you're in Jira, you can talk to a chatbot there, and in Cursor, connected to the MCP tool, you might see a to-do that you want to address, but you don't want to get distracted on what you're actually doing, so you just assign the work as you go past. And to make Copilot more effective at the task that we were assigning, there were a few customizations that we needed to make. So first up was the custom instructions, which is just system prompt that you give to the LLM. So you could tell it what build system you're using. You could give it a copy of your style guide to make sure that it doesn't, nest ternary operators or things like that. Then we had to set up the virtual machines differently. So we use private repositories for our internal packages and dependencies. On the front end side, we use Verdaccio for that. We've got kind of Maven and Gradle on the back end side. But the thing that really makes the difference between good and bad is connecting to them to the proprietary context using MCP servers. So I've got one example listed of what the configuration looks like, but we have MCP servers for Jira, Notion, GitHub, Slack. All of these places can be really important sources of information that allow the agent to do a fantastic job instead of just taking a wild swing at it. In many complex cases, though, that wasn't quite enough. So there's one other layer that we have added here, which is agent definitions. So by agent here, I just mean a combination of specific prompt instructions and MCP tools available for a more nuanced task. So OpenAI's advice in this space is to have a very large number of small agents with a small set of capabilities rather than aggregating them all into one large prompt, because LLMs do better with less context on a more specific task. So to give a specific example of how we've been using this, at Faire, to ship our code to production safely, we put things behind feature flags. Once you've turned the feature flag on, you then rip out the branch of code that's no longer relevant, conclude the experiment, whatever the case. So we have one agent that detects when settings are ready to be cleaned up. We have another agent that figures out what the next steps to clean it up are. And then we have an MCP tool that delegates that work to Copilot. So you're able to engage with us in a Slack channel and tell the bot, hey, can you go find another setting to clean up? And using the agents, it'll figure it out, but it can then throw away all the context that it consumed to get its answer and use just the answer to then go to the next step and talk to the next agent. And this kind of unblocks the constraints that we have on context windows. Another big buzzword in the industry is swarm coding. So this is something that we've really lent in on here at Faire. It's very exciting to see in action. But what I mean by swarm coding is The concept of swarming in programming has been around for a long time. It's when you mobilize a large number of people to work on the same task so that you deliver that task faster. And when I'm talking about swarm coding, I'm saying we're taking that technique and just leveraging background agents to achieve it. So you're able to parallelize multiple tasks that are small segments of the same overall large chain. So let's imagine that you need to migrate from one testing framework to another or one API to another. And there's 100 different changes that you need to make. You can't feasibly review that in one pull request. So dividing and conquering, but you do it horizontally, scalably, because you can just assign it to background agents, and the bottleneck just becomes reviewing the code for quality. So let's talk about what kind of impact we've seen with the background agents. So the way that we measure the impact is to divide our engineers into groups of people that have adopted the tool and those that have not. And we compare their pull request throughput before we adopted to afterwards. We also take a look at our overall percentage of pull requests that are coming from the background agent. And it's not a perfect measurement, but it does give us a signal that things are trending in the right direction. So at a very high level summary, what we see is that about 25% of our engineers are landing, as in merging into the main branch, at least one Copilot authored pull request per week. So that's 1 in 4. Of those users, they're on average throwing about a third of their workload at the background agents and doing 2/3 of it manually, the old way. And our overall pull request volume is anywhere between 5 and 10%, depending on the week, which is pretty exciting. I actually got off a call with the GitHub Copilot team this week, and Faire is in the top 3 of all enterprise customers for pull requests per GitHub user. So as you can see, that's like a pretty significant unblock just because we're able to do it from contexts like Slack chat. So why only 25%? There's quite a few reasons that kind of block people. A lot of it is just education, cultural shift, and we've attacked that with kind of a 5-week AI bootcamp that we wrapped up recently. But more of a bottleneck is that a large proportion of our users are backend engineers that are developing in the Kotlin stack with requirements that are actually really hard to meet with Copilot's default setup. Even with some of the customizations, we're not able to vertically scale the machines to handle the really large test suite. So with that, I'm going to hand over to George, and he's going to talk about what we've built in-house to tackle that problem. Thanks.
Hey everyone, I'm George, an engineer in the developer productivity team. Today is a very exciting day because I get to tell you about a project we've been working on called Cyberpunk. So here's our fancy mission statement. I'm not going to read that out loud because I don't want to butcher it, and it sounds much better inside my head. However, our intent with this project is pretty much what this says. We are building a system that can make developer lives easier by having an AI agent be omnipresent throughout their day-to-day workflow. So why the name? We wanted to build an AI background agent that can engage with Faire specifics while being able to act as a bridge between the myriad of LLM providers out there. So we imagine this to be something like a cyborg that can swap out any part of itself based on the functionality that it needs. Naturally, you might ask, why build? The short answer is that we considered it or considered buying, but decided that external providers did not meet our expectations. What are these expectations? Firstly, most systems have limitations with respect to the interface you could use to kick off an AI agent task. For Cursor, this would be a human opening up a background agent tab and writing a prompt. In GitHub, it's opening an issue against the repository and assigning it to Copilot. Though there are workarounds around this, we wanted our system to be capable of listening to any internal developer interface. Secondly, our repositories and their validation often depend on access to other internal resources or services. For example, we require numerous containers to be running in environments that run our integration tests. Building these into the external tools are either super tedious or downright unsupported. However, we actually did solve this problem ahead of fully virtualizing development environments as part of an initiative to improve local development experience. Thus, this kind of gave us an extra nudge towards the build option. Much like our friend Optimus, background agents that resemble Copilot could do more than generate code. There are multimodal LLMs that can read, review, track down answers that you need. However, most of the tools out there are also built for the broader market and are usually focused on one thing. There is a tool for generating code, another one for reviews, another one to track bugs, all with their own subscription formats and token costs. When you have a system of your own, it's easier to solve several of these problems with the same thing. So we came up with a simple diagram for starters. The intent is very simple. Messages from any Faire interface should be able to go into an orchestrator that hands off a prompt to an AI agent. The orchestrator itself will be the middle layer that brings together the interface and AI workspace, while also allowing the capability of defining custom AI workflows. The workspace is just a sandbox that AI can freely use to do its thing. Quick shout out to our vendors for these remote workspaces. They're called Crafting. Definitely look them up. So as the workspace generates output, it can either feed back to the orchestrator for more downstream work or make an output to any Faire interface. The AI workspace in diagram form looks like this. It is totally decked out to do autonomous workloads. It hosts all the containers that we need for code-based validation. And all of these workspaces are also pre-warmed for immediate work. Each workspace hosts an AI executor that wraps Claude code, and it constantly polls for new work to do. The executor has access to sub-agents and rules similar to how Claude code would when a user invokes it. For example, if someone from the backend team wrote a new rule that they needed followed in the repo when new folks used or worked on a specific area of code, or if they added a new sub-agent that needs to or should get invoked when validation needs to run, once they commit this, it naturally becomes available to the AI workspace. The orchestrator is just a simple system that you can add new tasks to. A task might be something like edit a PR, start a new one, or answer a question. For each task, the orchestrator breaks down the larger problem into prompts that the AI workspace can use to solve. So this helps ensure that the AI doesn't totally go off on a tangent because of very large prompts that ask it to do a lot of stuff at the same time. For example, a task like edit a PR would involve three things. One is to actually check out the main branch or whatever default branch is for the repo. Secondly, do what actually needs to get done or what the user asked it to do. And finally, push out a PR, notify people, things like that. The orchestrator also, in our case, is what decides how many AI workspaces need to come up based on the request load. So because of the work we did here, we now have a more powerful Faire-specific agent that is able to jump into work at any time. The AI agents can run our complete validation suite and can be invoked from any interface. And finally, our system is not limited to generating code and is able to incorporate a myriad of workflows. So tomorrow, if I need this system to read code from main and answer a question that involves a subset of MCPs, it would be a trivial thing to add. Now I'm gonna hand off to Megan.
Thank you, George. Hi, everyone. I'm Megan. I'm an Android developer at Faire, and I'm here to chat about how we've been applying AI tooling in our day-to-day workflow. So the first thing I want to say is, as Luke previously mentioned, there are a lot of AI tools out there and more being created every day. There's tools to help you code, review PRs, summarize docs, write docs. And in this talk, I'm going to go over 2 specific examples about how I've been able to leverage AI to accelerate my workflow. But my biggest takeaway from working with AI is that it's very important to experiment with these tools, since taking 10, 15 minutes out of your day to learn and master them can end up saving you hours or even days in the long run. So the upfront investment is definitely worth it. So getting into more specifics, the tool I've been most often using in my day-to-day is Cursor, which I have a screenshot of here, which George briefly name dropped. Cursor is an IDE that has an integrated chat panel that you can use to prompt various different AI agents, such as Claude, GPT, or Grok. And you can see that it's set up with the code on the right, and it has the chat panel on the left. It's a fairly powerful tool that can be given specific files as context. To reference, it can also write code directly into your code base, and it can even be given permissions to run certain test files to make sure that the code it's written is working correctly. There are other tools out there that do similar things, such as GitHub Copilot, which Luke chatted about, Claude Code, or even more Android-specific tools, such as Gemini or Firebender. But I've currently been using Cursor, since that's what Faire is most often supporting. So there are more internal programming and tooling set up to work with Cursor. However, you can get similar results from other tools as well. So now I'm going to go over some specific case studies where I've been able to leverage AI in my day-to-day. And first we have this bug. So our app typically has a white background, but for our Faire markets, we wanted to update this to be a dark red color to fit with our theming. However, because our app is typically has a white background, that means that the status bar icons at the top of the app are usually set to black. But with this new dark red color for markets, these black icons become a bit muddled and difficult to see. So we wanted to update them to be white. However, because this background color was going to be backend driven, we wanted this to be able to be done dynamically, since we didn't want it all to be hard coded about whether the icons would be light or dark. But I wasn't really sure how to do this, how to dynamically determine whether a color was dark enough such that we should switch to the white icons. So this is where Cursor came in, and I gave it something similar to this kind of prompt where I wanted it to update the home screen view to dynamically set the status bar icons to white or black, depending on the background color of the status bar set by this parameter. And it spit out something similar to this. This is color light function, which is exactly what I wanted. If the background color is light, the icons can be black. And if the background color isn't light, then we can set it to be white. But as Marcelo mentioned, AI is has a lot of knowledge, but can be very dumb. So I wanted to understand what Cursor was doing here. For example, this val brightness value, I didn't really understand where these constants were coming or what it meant. So I wanted to dig deeper. When I Googled it, I found this Wikipedia article, Luma Coding in Video Systems. So it seems that Cursor was able to pull a fairly valid way to determine brightness in code, maybe not the best way, but definitely a way and a starting point. By looking into this problem further and striving to understand the code that AI was generating, we were able to not only verify the code that the AI was generating, but also able to learn more and become a better coder as a result, since now I actually know how to dynamically determine a color's brightness. This just goes to show how Cursor can help in your exploration phase and solve problems in ways that are completely outside of your knowledge base. Now, for my second case study, our team wanted to add this See More page. The Faire homepage consists of a lot of carousels of products or brands, and we wanted to add a little arrow in the carousel title. So when a retailer clicked on it, they could see a list of all the products or brands related to that carousel. They could see more of what they were looking at. This was going to be a very simple page since it was going to use our server-driven UI, which meant most of the logic of this page was going to be pushed off into the backend. However, to write an SGUI page, it took a lot of lines of code, about 800 lines to be exact, which even just to write that amount of code takes a decent amount of time. Therefore, though this could be done by developers, we decided that it was a perfect candidate to use AI to save us time. As I mentioned, this new page was going to use our server-driven UI, which because of the way our system was set up, that meant that this page was going to be very similar to other pages that were using server-driven UI, specifically our homepage and our category page. So, as you can see in the prompt below, I gave Cursor a list of all the homepage and category pages, and I asked it to pull the commonalities out of those 2 pages to create this new file. I also asked it, or told it the specifics of the API for this new page and told it to write some tests. Cursor was able to generate basically all the code first try with just some minor tweaks and adjustment, but using Cursor in this case saved a ton of dev time. If I were to estimate how much time this would typically take without AI, I would say about 2 days to get all the code written and ready for review. However, with Cursor, we were able to put up this PR in just under 3 hours. This demonstrates that AI is very, very good at writing code, especially if it has very similar examples from the code base that it can pull from. So lastly, I just want to end on some general knowledge of how I've been using AI in my day-to-day workflow. I've separated this out into 3 different sections, specifically exploration, evaluation, and execution. And I'm actually going to start at the end with execution, since I feel like that's what most people think of when they think about coding with AI. This could be generating code or generating tests or refactoring code. And we can kind of see this example in my see more page example, where it just generated the page for me. However, we can pull AI earlier up into our workflows to also accelerate those processes. For example, when you're exploring a problem, it can help you search internal tooling better. It can help you search and summarize large code bases, since AI can read code a lot faster than we can. Or it can help you do external research. For example, figuring out how to dynamically determine if a color is bright or dark. Lastly, in the evaluation phase, it can help us generate diagrams or technical plans to solve a problem, and it can even be used to help you scope the difficulty of a problem or solution. All in all, I hope from this talk you're able to find somewhere in your workflow where you're able to add AI to speed up and accelerate your development process. And now I'm going to pass it off to Tom to talk about natural language and image searching.
Hey, thank you, Megan. My name is Tom. I'm an engineer manager on the Discovery AI team. Today, I'm excited to walk you through how we're using AI to transform the discovery experience for our retailers. So most of our retailers kick off their product hunt right in their web browser. They type in keywords on the search bar, scroll through the products, and only rarely they apply filters, which is less than 10% of the time. Instead of applying filters, most retailers keep on tweaking their search terms and guessing the way to the right search result. Filters could make this faster and more precise, but today they are clunky and hidden. Now let's see what our retailers say. Here are some straight from retailers' feedback. I wish I could search the way I speak to my sales rep. Show me something like this, but more in blue and at a lower price point, rather than trying to break it down into separate searches and filters. This is exactly the experience we want to bring to Faire, where AI-driven natural language search. All right, let's see it live. Oh, how do I go back? Okay, yeah. All right, now let's see it live. Here, the retailer is typing in, find me dresses made in Paris under $100 and now sold on Amazon. And just like that, our system understood the user's intent and applied multiple filters. Location, price, and brand value now sold on Amazon, all from a single natural language query while keeping dresses as the primary search term. There's no hunting through menus and toggling checkboxes. That's the power of AI. Now, I'll walk you through how we built this under the hood. So natural language search used to be a tricky problem. Free-form text is messy, and translating user intent into something our search engine understands isn't easy. But thanks to AI, we created a working prototype in just less than 2 days. Here's the flow when a retailer types a natural language phrase. So client would actually send a search request with that raw natural language query to our search service. We then take the raw text to AI, and with some prompt engineering, AI would be able to return a clean query plus filter parameters. After that, we turn this process search query to a search engine to perform a text plus filter search, where our search engine already know how to best handle it. So essentially, we turn natural language search in a 2-step flow, where we use AI to turn natural language into text and filters, and then text plus filter search via our existing search engine. This is just a smart way to leverage AI to build something fast and useful for our retailers. Now let's jump a little bit ahead into our mobile search experience. So our phones has been a game changer for most of our retailers. They browse Instagram, Pinterest, or snapping pictures at trade shows to find inspiration. But when they spot a look they love, finding similar products based on that inspiration is a total shot in the dark. Now let's see what our retailers say. Here are some feedbacks directly from the retailers. When I see a product in person or online, and I want to find something similar to, I have no way to use that image to search on Faire. That code nails the problem. our retailers cannot turn visual inspiration into actionable searches today. Let's see how our AI-driven image search help with that. Okay, let's watch it live. So on my phone, I tap on the camera icon and pick one of the Pokemon photos. It's called Snorlax. I found it on my Instagram feed and hit search. Just like that, our image search returns Faire product that either match or inspired by this Pokemon image, all in one tab. There's no typing, no guessing keywords. This is pretty cool, right? Next, I'll walk you through how we build it under the hood. Image search used to mean building expensive computer vision pipelines, and it used to be very costly. Let's see how we can build it with AI. So here, when a client sends an image to search, behind the scenes, we hit AI, and with some prompt engineering, AI will be able to turn that image into a clean text query, in this case, Snorlax. Then we take the AI-generated text and call a standard search service, just like any other standard query search. Here, we basically break down AI-driven image search into a two-step flow, where we turn image to text via AI, and then use text to turn into products via our existing search pipeline. And as simple as that, we now have image search at Faire without building the expensive computer vision flow. As you can see, AI makes a lot of these used to be complex problems now pretty simple to solve. Here are some customer outcomes. We turned our prototypes into actual discovery features and launched it to our retailers. We launched image search on mobile, and it's already powering 1% of all mobile searches. A huge signal that retailers love typing on a photo instead of typing on their phone. And on the natural language search side, we opened our beta to customers who are now testing freeform queries in production. Next up, I'll share a few more prototypes we're now exploring. What you've seen so far is just the beginning of our vision to reinvent discovery future at Faire. We're now reimagining discovery from the ground up, letting retailers explore by web, refine with simple feedback, and instantly surface the perfect product for their shop. AI is an important foundation that unlocks powerful new capabilities to serve our customers and help them curate the truly one-of-a-kind shop. Now I'll hand it to Luan to dive into our next topic on Project Burrito.
Okay, thank you, Tom. So my name is Luan. I'm also an engineer here at Faire, and I'll be talking a little bit to you guys about Project Burrito. As we can see, we have really cool names for our projects. But let's take a step back. So let's think of a user problem that started all this. So this is a fictitious character that we have. Mary is a Faire account manager. So her job is to up-level the experience of our retailers and give them a customized, curated experience at Faire. One of the things that this profile will do for retailers is basically create an assortment of products that they might want to purchase at Faire. So this is not just a single search for a single product. It's creating a really collection of products that work well together, that match the vibe of the retailer, their price point, that satisfies brand minimums and other restrictions. So it's a very iterative process that Mary is doing for the retailer. While we could build some API to help Mary here, and if we build, in the traditional model, we could do a very, step-by-step thing that would be extremely brittle, because this is a very, exploratory process that Mary is doing. So with all these new talks about agentic AI, we thought that might be the perfect solution for this kind of problem. And we decided to give it a try. However, as we investigated more about agentic AI, it turns out we discovered that, well, basically under the hood, it's a bunch of Python libraries. And while we could, recreate these things relatively easily, or we could, find other libraries or other things in other languages to replicate this, we wanted to be on the bleeding edge. So we know that the community has kind of decided that all these new agentic AI things are going to be mostly done in Python. And also we have a whole data science team at Faire that loves Python and has been working and building a lot of libraries and tools using these Python APIs. So basically we thought, well, could we maybe use Python as well? So we ended up in this scenario here. We've played a lot internally with AI, as we have seen from my friends before. And that is mostly through what we call Faire, which is basically a supercharged Node.js server with lots of integrations. So that's mostly internally, that's in Node.js, and that connects, to GitHub, to Jira, to everything we have internally. Then externally, we have our production servers. So our production servers run on Kotlin, basically. We have a web of microservices in Kotlin. And finally, we have all these Python APIs, agentic programming tools that we want to leverage. So with all that in mind, we came up with basically three kind of requirements for this particular use case for agentic buying. Not only for this, but we could leverage this to build other tools for retailers as well. The first one is that we have these different platforms. So in this case, we might want to, while we think Kotlin is still like the best language for general purpose servers at Faire, we wanted to be able to leverage other technologies for very specific purposes, such as running this AI agents or even other things in the future. Number two is we potentially want this to be user-facing applications. So while the first application here was to build a tool to help Mary, which is a Faire employee, if the tool is really good, we could just enable retailers themselves to use the tool. Or in the future, we might want to build tools for other types of users. However, whenever we're talking about user-facing things at Faire, we have a really high baseline for certain levels of requirements, including security, availability, observability, all that kind of stuff. So we want to leverage the expertise we already have on that area. And finally, the whole reason we want to leverage this AI agents is that because we want to create something that can act as the user in some capacity. So basically, we want to build something that can, for example, perform a search at Faire, the same way that a retailer would, call the search API. We want some iterative agent that can do that kind of thing, could also access other Faire data sets, for example, and kind of combine and iterate on all that information, in this case for the agentic buying, to create the assortment of products in the end. So you might think of it, for example, calling a search API first and then figuring out, oh, those results are not so good. Let me tweak the filters, for example, just like a human, just like Mary would, right? So with all these three kind of requirements in mind, we decided to move forward with what we end up calling Project Burrito. And in order to understand how it works, I'm going to take a little bit of a step back, and I'm going to show how things were before Burrito. So as I said, we have our Kotlin backend infrastructure at Faire, and we have what we call the macro service infrastructure. And the reason I call that is because it's not just microservices that you have, hundreds of services, and you end up in that integration hell where you can't get anything from any service. We have just a handful of slightly bigger services, so we can fly away from the monolith, but they still make a cohesive sense and they can operate autonomously. As you can see, each service here is kind of very isolated. They all have their own Kotlin server, of course, but they also have their own data store, so their own database, which can be a MySQL or CockroachDB database. And they only communicate between themselves by using RPC calls or by using an event bus. And then, when request comes from front end, we have some Nginx equivalent proxy in front to just route the requests accordingly. So that's how, it worked until a few months ago. But then we decided to introduce Project Burrito. So what is Project Burrito? Well, we're adding a new service to this cloud of services, and that's called a burrito service because just like a burrito, it has a thin Kotlin wrapper around, and then you have the filling of the burrito, which is something else, so some other server. So we have a single Kubernetes pod that actually runs two containers. It runs the Kotlin server just like all the others, but it also has another application server, which we call the sidecar or the burrito filling. That other server can be in any other language, and again, that goes with the goals of the burrito project. But in this specific example, of course, it will be a Python server. And the benefits here is that one, the wrap that interacts with all the other services is completely standardized with the rest of our infrastructure. So for any other service or the front end accessing the service, it looks, behaves, and feels just like any other Kotlin service. However, internally, it can access the advantages of using the different language. Another benefit is that we can delegate to the Kotlin whatever we know and love and already explored and it's good at in Kotlin. So we have a big ecosystem of existing, strongly opinionated ways of doing certain things, such as database access. We want it to be type safe, settings, access control, any sort of those things that were already built and developed in Kotlin, we can just reuse in the same way that we do with any other service. However, anything that we want to use the specific new thing, the Python agentic AI thing, lives on the filling side. And then communicate using protobuf, which is the same standard API protocol that we use to communicate between services. We just run local host HTTP requests within the container. So this follows most of the structure and good practices that we have developed over the years and allows us to explore and to use new technologies as they emerge. In this case, all the agentic AI thing. So I've been talking a lot about the infrastructure, but let me actually, well, first of all, we created the burrito. If we have an accurate representation here of the first burrito being birthed. And let me actually show you what the actual application looks like. So as I said, it's a simple, deceptively simple interface with basically just a text prompt and returns a list of products. But what's going on under the hood is extremely complex because it's not just running a single search. It's actually calling the Kotlin wrapper, which does a lot of preparation. For example, it does session delegation, which is a mechanism that we developed so that the AI can go rogue and do things that it shouldn't. It actually gets a very restrictive set of permissions of what APIs it can call. Prepares a lot of the data, and then call the Python, which starts LLM with, which is equipped with all the agents to do things such as calling Faire APIs, like the search API, potentially other APIs, connecting to Faire data sets, again, with all considerations for security and making sure that it only has access to the specific things that it's supposed to. And then it can actually iterate on all those APIs and compile this, what ended up being called an assortment, which is just a collection of products, but it's actually a curated list of things that go well together, like a set of things that goes nicely in the retailer shelf. And that's just the beginning. Firstly, we want to explore much more on Project Burrito. Not only we want to make the infrastructure better for the existing burrito that we created, which is it's called AI tools because we're building other tools as well. But we want to expand it in the future to have other burritos with other technologies, not only Python, but if there's some other user problem that we want to solve, where we realize that Kotlin might not be the ideal language, or there is some existing standard that we want to follow, we'll be able to use Burrito for that. And on the other pillar, we also want to improve AI tools specifically. So we called it AI tools because we're actually building a set of tools that leverage agents, AI agents, LLMs agents, in production to help retailers and brands. So one example of the tool we're building right now is called the Order Insights tool. And this tool, basically, it gives access to the LLM to the entire history of orders of that retailer and allows the retailer to query the LLM and ask questions. So for example, if they want some statistic, or basically think what you as a developer would write like a SQL query to figure out, now we can empower the users using natural language to figure out stuff about their data and get insights about their business, what they're buying, what they're selling, and all that good stuff. And I think that's all I have. So I'm gonna pass off to Angel. Thank you so much.
It's a tricky transition. Okay. Hi, everyone. My name is Wen Hao. I lead the discovery, AI, and machine learning efforts. So you've been talked at for a while. So I have a favor to ask. Would you please stand up if you're sitting, please? Just stretch your legs a little bit. Thank you, thank you. Great, amazing. If you want, please sit down. Okay, this is just like let's change the energy a little bit. Cool. So I realized that I am the only person or only thing standing between you and the happy hour, which is usually a pretty dangerous spot to be in. So I'm gonna do my best to entertain and most importantly, get out of the way fast. So we talked quite a bit about how Faire is using AI to kind of introduce new user experience and integrate into our workflow to make things more efficient, make everybody more productive. This is going to be a slightly different talk where I'm going to crack open the black boxes even further and show you how we train some of the models at Faire. So Faire is a two-sided marketplace with our brands on the demand side, the supply side, and retailers on the demand side. So in a nutshell, Discovery Pillar's job is to match retailers with brands so that they can build a long-lasting and mutually beneficial business partnerships. So that's our mission. And discovery happens really just almost everywhere at Faire. So search, homepage, brand page, and product detail pages, there are quite a few, and ads. So together, these surfaces account for the majority of Faire's order volume, and they are responsible for helping retailers find brands and products their own customers will love. So behind every surface, there is a collection of algorithms. So internally, when I say like algorithm, we usually refer to the combination of machine learning models, including LLMs, and agentic systems. These algorithms determine what shows up when each retailer search or land on the surface, like the homepage. So what is our goal for these algorithms? On the one hand, we optimize obviously for conversion, such as order volume or ads conversion. So these are top-line metrics that indicate to us whether Faire is successful in helping our customers grow in their business. On the other hand, we also care deeply about user engagement, such as clicks and add to carts, and other leading kind of indicators of a healthy marketplace. For example, brand and retailer relationships that we're able to create. And we're successful only if we can balance these two sides of near-term and long-term. So here I'm showing you like a pretty accurate high-level representation of our system architecture, which kind of follows a pretty standard industry sort of best practice or common pattern, which is cascading pattern. And it usually start from some kind of query understanding and processing to candidate generation, to ranking, to some kind of post-ranking optimization. And every stage has a bunch of machine learning models that we can train and iterate on to improve and fine-tune the system performance and behaviors. So I'm going to use search retrieval as an example. So here we're combining multiple different retrieval sources that are built using different machine learning methods. So from semantic embeddings, graph retrieval, and so forth. These retrieval sources complement one another to provide strong candidate set for downstream ranking stage. And our ranker uses what is called deep and cross network architecture. The model itself is trained on millions of records and has hundreds of dense features and embedding features. It's trained on typically list-wise objectives like lambda loss, if you're familiar with ranking model training. This allows us to train the model so that we can balance multiple different factors that drive conversion, such as relevance, product quality, and retailer level personalization. And so far, what we've learned is just by iterating on these canonical cascading architecture, within the confine of more kind of traditional machine learning, deep learning algorithms, have enabled our team to deliver very clear and tangible business impact as well as values for our customers. So far, I haven't touched on anything related to the buzzwords. So you might wonder, like, okay, this is fine. Like, where does AI fit in? At least in its latest iteration, which is when we think about AI these days, we think about like LLM, generative models, or agents. So to answer this question, first I want to talk about some of the key challenges we as a team tackled. So I'm going to highlight only two due to time constraint. So one is data sparsity, and the other one is the complex marketplace dynamics. So these are the very unique characteristics that make Faire's AI and machine learning model, problems very different from many other platforms that you might be familiar with. So first, data density. As a B2B marketplace, Faire serves retailers who may only order from us like a few times a month or even less frequently. So in general, we have significantly lower traffic compared to a consumer-facing platform with a similar GMV or revenue. So by nature of our business, we're constantly working within the tail or long tail data paradigms. And as you know, modern day machine learning models are very, very data hungry. And so this means we do have a problem when it comes to training machine learning models. So what do? One of the first things we tried, which turned out to be very successful, surprisingly so, was we turned to LLMs. We specifically leveraged the world knowledge that these models possess due to extensive pre-training. And we fine-tuned them for our own use case, typically using low-rank adaptation methods, such as LoRA. So we fine-tuned, for example, Llama 3 to create a Faire-specific search relevance model. And we then distill that to smaller models to optimize for inference efficiency. So this workflow really improved our ability to measure and improve semantic understanding in search. And even though we're working with low data regime, this has proven to be extremely effective. So the table I'm showing here is from one of our blog posts. So you can see the progression of, you fine tune with the larger models or with more data or the right data, the accuracy contrast, especially when you compare that with the accuracy we were able to get from purely prompting frontier models. We also fine-tuned this model called Lava, which is a large vision language model that combines text and image input to classify products into thousands of fine-grained taxonomy types with extremely high accuracy. I think our production baseline was initially 70%. We were able to push this to 95%. We factor in the fact that, again, this is a classification problem into thousands of categories. You'll appreciate the progress we're able to make here. So beyond fine-tuning frontier LLMs, our teams also, as you seen in the previous presentations, we started building agents. One key insight is that new retailers or users who haven't had a long history or a lot of engagement activity on Faire, it's very hard to train personalization embedding models for them. But we do collect very rich data and image and structured data during their onboarding process. So based on that, we created our own kind of deep research engine, which analyzes raw retailer data to build multi-model, what we call internally retailer profile that can be used to power personalized recommendations, even in cold start settings. So you kind of bypass the embedding and training stage, go straight to what I know about you based on your text description, your listing on your website, and to personalized recommendations. So now I'm going to move on to the second challenge I mentioned earlier, which is marketplace dynamics and objectives. So in the marketplace, it's just not enough to optimize for only near-term outcomes, like conversion. We also have to focus on long-term health. A key indicator of a healthy marketplace is high density or thickness, having enough participants in the marketplace to create real choice and efficiency. So this is the kind of stuff like economists have known for a while. And one of my PhD advisors often emphasizes how important it is to first start working on the marketplace density. So at Faire, we always keep in mind the complex dynamics, and we intentionally prioritize investments in its long-term health. So concretely, what does that mean? It translates into some very crucial design choices we have to make for our algorithms. For example, exploration versus exploitation. Do we show new options, or do we double down on things that we already know that will work? Balancing near-term conversion with a long-term trust and health. So we don't optimize only for clicks. So this is how we avoid kind of clickbaity impressions. A technical challenge we face comes from the fact that we are using a cascading architecture. So the design is really driven, if you think about it, driven by compute efficiency. We need to handle millions of candidates quickly in real time. But every stage of the pipeline is created separately, trained separately. So it can be very difficult to align all these stages towards a single set of goals. If you think about training an end-to-end kind of model versus having to piece together different things that are trained on different objectives, that's where the alignment problem comes in. So now I'm going to share some of our latest and very much work in progress thinking on the path, what the path forward might look like. And you'll know the caveat because I'm having a star on the title of the slide. This is extremely exploratory. But if you follow the research on LLM training, especially in RLHF, you'll find this section probably familiar. So the first step is we try to replace the cascading system with a generative sequence prediction model that is trained end-to-end to handle everything from query, understanding, retrieval, and ranking. So the next thing you do is to introduce reinforcement learning training loops. So this allows you to directly and jointly optimize different objectives, including conversion, but also your various kind of marketplace objectives. And we are able to also kind of explicitly nudge the models to balance exploration versus exploitation. And last but not least, we also deploy, as we deploy more agentic systems, and which is obviously extremely powerful, we're also going to be able to collect more agent rollouts. That way we can actually swap out some of the closed source frontier LLMs with reinforcement learning tuned open source LLMs as the intelligence engine for the agent. So this is really exciting because number one, it gives us a more cost-effective and low latency kind of serving option. It also allows us to take advantage of the data flywheel and directly optimize agent performance by fine-tuning the LLM that powers these agents. So I hope this gives you a sense of what our system look like, the problem we're trying to solve, and sort of how we're thinking about the path forward. I'm going to do something that's a little risky, which is kind of predicting the future a little bit. The risk being I'm for sure going to be wrong. But look ahead, we think AI will for sure dramatically transform B2B wholesale. Users will definitely expect much smarter and intuitive experience. Our system will have mixed use of frontier LLMs and specialized in-house machine learning models. And instead of manually kind of composing different components together to accomplish a task, like what we do within our cascading system, we will build these models as tools, with agents being the sort of intended users. We'll take advantage of both closed source frontier LLMs and continue to fine-tune open source LLMs for our own use cases. Personally, I'm very excited about Agent RL because I think it will make improving AI agents more scalable and running AI agents more cost-effective. And in this highly dynamic system with autonomous behaviors, we will have to operate with a slightly different mindset. It will require deep probabilistic thinking and very careful management of various kind of uncertainty and surprises. Like I said earlier, when you predict the future, you're guaranteed to be wrong. So, but I hope that's not the takeaway you have from today. Instead, if you are energized by our mission, the problem we're solving, I would love to see if we can work together. Thank you for your time. If you have any, I know I just went through a bunch. If you have any questions or thoughts or feedback about what I just shared, please find me after this. During the happy hour, I would love to meet you all. Thank you.
All right. Now I'm the only person standing between you and happy hour. So we just wanted to highlight all of our great speakers tonight. We're all here If you'd like to chat more with us, we have our office open for the next hour. Thanks so much for coming out. And yeah, we're here to answer your questions. Thank you, everyone.